Okay, so here's the spring 2020 version of solving exponential equations using logs. The other day during the Google Meet, I noticed that that one recording was pretty out of date, so I'm going to do this and just show you the way we do things now. Most of the stuff is always the same, but so change of base, how does that enter in, or why does that enter in? So let's say we have log base 3 of 81. Now we know what the log base 3 of 81 is, right? Because a log is an exponent, and it's 3 to the power of what will give you 81. And so we know that that's equal to 4. But let's say we didn't know that. How would we work this out on our calculator? Because our calculator can only do, I'm just going to bring the calculator in here. Our calculator can only do a base 10 log or a base E log. All right, hang on, I'm going to see if I can drag the calculator over. There we go. Get it onto this screen. All right, so there's our calculator. So on the calculator, we can't really do base 3 log, right? We just have this log key, log, and that's a base 10 log. So how are we going to do this on our calculator? Actually, there is a couple of different ways, but if you have an older calculator, there is only one way. So how would we solve this? So let's say that we say y is equal to log base 3 of 81. And if we put that into exponential form, our base is 3, our exponent is y, so 3 to the y is 81. Now this is something we could have done in exponents, right? Because we can write 81 as 3 to the power of 4, and then we would just say y equals 4. But that wouldn't work if this was like 40 or 17 or 29 or something. So how would we solve for that? Well, we use the laws of logs, and that is, if I take the log of both sides, so the log of 3 to the y is equal to the log of 81, then the power rule allows me to then write this as y times log 3 is equal to log 81. And you notice when I took the log of both sides, there's nothing written down here. It's a base 10 log. So that means that y is equal to log 81 divided by log 3. All right, let's give that a try on our calculator. So log 81 divided by log 3. And that should be equal to 4. And it is. So that's called the base change formula. Or that's the change of base. What it looks like as a formula is this. If we have a log base b of some number, we can change that to any other base. So let's say I want to change that to log base a. So we take the log base a of the value. So notice here, right, we had log base 3 of 81. We want to change that to a base 10 log. So base 3, the 81 is our x. We'll do log, now we would go base 10 of 81 over log, and you notice what we did here, log base 10, or base a of the base. Now, this would be on the formula sheet, this base change formula. And so, just to parallel that, we did log base 3 of 81. We want it as a base 10 log. So we do log base 10, that's the base we're going to change to, of the value, so 81, divided by log base 10, log base 10 of the base, the original base. And now, as we saw, we can enter that into our calculators, and we can work out a value. So how does that help us, or how do we use that? Basically, we have an expression, an exponential expression, and we want to change that to a log to solve, then we can do that. And we'll see that in a moment. Okay, so we're back, and we have this money problem. We have $800 to put into a GIC, that's a guaranteed investment certificate. The interest rate is 1.8% per year, per annum, compounded monthly, right? So that's 12 times a year. Ignore the dogs. How long does it take for our money to at least triple in value? So here's the compound interest formula. A is equal to P times 1 plus I to the n. So A is the final amount. So if we're going to triple, we're going to end up with $2,400. P is the principal of the initial amount. I is the interest rate per compounding period. Now, 1.8% is 1.8 divided by 100, or 0.018. So 0.018, but it's monthly, so we divide that by 12. And then n is the number of compounding periods. Now, if I just use n here, this n, then what I will come up with is, I'll come up with how many months. Now, normally if we were working out a value here, so if we were just, we had an n, then our n would be in months, and so if we knew it was like 5 years, we would be putting here 12 times 5, or 60. Okay, so we want to solve this. We're going to use logs. So our first step actually is just to simplify this. We'll divide both sides by 800. So 3, because we want our money to triple, so we got 3, is, now I can actually work out the 0.018 divided by 12 and add 1 to it, and I get 1.0015 to the power of n. Okay, and I'll just show that. We'll bring up our calculator here. So we had 1.8%, 1.8 divided by 100, right, because it's got to be a decimal. And then we'll divide that by 12 because it's monthly. And then we'll add 1 because it's plus 1. So 1.0015. Whatever you do, don't round this value. Okay, you'll just throw all the calculations off. I guess I can leave the calculator out for the time being. Now, we could do this 2 ways. So I'm going to do this 2 ways. I could take the log of both sides. So log 3 is log 1.0015 to the n. And then the power law of logs allows me, so I go log 3 is n times the log of 1.0015. And n will equal log 3 divided by log, excuse me, 1.0015. So log 3 divided by log 1.0015. Enter. And that's a lot of months, right? 732.9. So 733 months. How many years is that? Well, if we divide that by 12, we'll get the number of years. So 61 years. Or 61 years. So that's one way to do it, right? Taking the log. Hang on, I'm just going to move this over. Taking the log of both sides. Here's another way. So let's say we're starting with 3 is equal to 1.0015 to the n. Then all we say is, all right, let's write this as a log. So our base is 1.0015. So log base 1.0015 of the number 3, because that's the value we're going to end up with, is equal to the exponent n. Because remember, a logarithm is an exponent. So that's the exponent n. So what we would then do, if we had a calculator that we can't put the base in, we would then rewrite it as log 3. We'd use the base change formula, so the log of 3 divided by the log of the base, right? It would be just exactly what we see here. Now on a newer calculator, if you go alpha f2, number 5 is log base. Okay, and now we can put in the base, 1.0015, and then we arrow over, we put in 3, we hit enter, and we get our 732.93. Okay, and we'll do a few more examples where I will show you log base. But if you don't have a calculator where you can do log base, then you just simply write this as the log of the value divided by the log of the base. 0.015, right? And that's what we worked out up here. Okay, let's make the calculator disappear. And let's do a few examples. So, I'm just going to pause for a sec while I write it out. So, let's say we had 4 to the x plus 2 is 75. Now, we know 4 cubed is 64. So if x was 1, this would give us 4 cubed, which would be 64. That's too small. And 4 to the 4th is 64 times 4, or 256. So if x was 2, that would be too big. So we know our x value is between 1 and 2, but other than until now, doing this graphically, we don't have a way to do this. But here's what we do. So we say my base is 4. So I'm going to do the log base 4 of the value to get me the number 75. And remember, a logarithm is an exponent, and the exponent is x plus 2, which means x is log base 4, 75 minus 2. Okay, now we've got to do this first, right? So on our calculator, 2 different ways. Let's clear this. So if I can do a log base, alpha f2, and number 5 is log base, I could put in the base of 4, the value is 75. Okay, we're going to work that out, and then subtract 2, and we get 1.1144, 0.9345. So if we round that, let's say, then x is equal to, let's go to the nearest hundredth, x is equal to 1.11. Now, if you can't do a log base 4 of 75, then you just use the base change formula and you say it's going to be the log of 75, so log 75, bracket, divided by log 4. So that formula is on the formula sheet, and you'll see you get the exact same number. So if I go 4 to the power of 2 plus 1.11, now remember that's the rounded value, we're going to get something close to 75. And if I go 4 to the power of, and let's bring down this number here, and then add 2, so that's x plus 2, then we'll get exactly, or really, really close to exactly, 75. Okay, I'm flipping over to one of the examples. It's actually on the newer worksheets we gave you. But what if you had something like 40 is equal to 8 times 3 to the power of x? So the first thing you need to do is you need to divide both sides by 8. So we need to simplify an expression if we can. So we'll get 5 is equal to 3 to the x. We're then just going to rewrite that as the log. Our base is 3. Our value is 5. We're going to end up with 5. And that's equal to x. On the calculator, so old calculator, you're going to go log 5 divided by log. So the log of the value divided by the log of the base. And on the newer calculator, alpha f2 Number 5 is log base. Put in the base of 3. Arrow over to get here, get the 5, and there we go. If you want to check that, you can go 8 times 3 to the power of, and let's just go pull that number down, and we get 40. Well, really close to 40, right? I mean, 40.00001, which is really 40. Okay, but you have to simplify this first. Otherwise, you would have to do the log of both sides, and we don't want to do this. But we would write log 40 is the log. So if you're taking the log of a product, it becomes the sum of the individual logs. Okay, don't do that. All right, so we're just going to simplify. Then we're going to change from exponential form to logarithmic form and use our calculator to work it out, using either the base change formula to go to base 10, right? So the log of the value divided by the log of the base, or if you have the base, log base on your calculator, you can do log base. Okay, let's set up another one. All right, let's try this one more. So, we could take the log of both sides, move that out front, but we're not going to, right? We're just going to write it as the log of the base. Now it's base 10, so I don't need to put anything there. The value is 200. And we end up with, remember, a log is an exponent, and the exponent is x minus 1. So x is going to be log of 200 plus 1. So log 200. Okay, now close that off, or work it out separately, and then add 1. And we get x is equal to 3.30, rounded to the nearest hundredth. So if I did 10 to the 2.20, 10 to the 2.20, we're going to get really close to 200. Sorry, 2.30, 10 to the, that wasn't all that close, 2.30, that's much closer to 200, 199.5. Okay, so, excuse me, in 1986, in Chernobyl, there was a meltdown in a nuclear reactor, and what that did is it released radioactive iodine-131 into the atmosphere. So, problem with that is that your thyroid could take in this radioactive iodine, and that could cause problems. So what they would do is give people in the vicinity iodine tablets so that their thyroid takes in the healthy iodine. So if it took 45.7 days for the level of radiation to drop from 100 units to 2 units, then what is the half-life? So determine, show your work. This will be a written question, the half-life. We're going to start with the formula. So you've got the formula. A is equal to A naught, 1/2 to the T over H. So A, the final amount, well, we're going to end up with 2 units. A naught, the initial amount, we started with 100 units. 1/2, because it's a half-life, so it's an exponential decay function, right? So half-life is a decay. T is time, so we know it took 45.7 days, and we want to find the half-life, which is H. Step 1, divide both sides by 100. So 0.02 is equal to 1/2 to the 45.7 over H. Now, let's write that as a log. So we'll change this. So instead of taking the log of both sides, multiplying and doing a whole bunch of work that we really don't need to, we're going to say it's the log. The base is 1/2, so log base 1/2. The value that we end up with is 0.02, and that's going to be equal to 45.7 over H. Now, if we look at this, we could cross multiply. So, hang on, I'm just going to drag this down a bit. So we have H times the log base 1/2 of 0.02. So this times this is 1. So we don't need the 1. It's 45.7. And the thing we want, the h, will be the 45.7 divided by the log base 1/2 of 0.02. So, okay, 45.7 divided by, okay, new calculator, alpha f2 log base. This base is 1/2. I can enter it as 1 divided by 2. Okay, and then kick over here and put in, and I can actually do this as 2 divided by 100. So I don't actually have to work out anything there. And we just hit enter, and we get 8.1. So h is equal to 8.1. And the units are going to be the same. So whatever the time was in, if the time was in years, this would be years. But time is in days, so that's days. Now, what if, old calculator, so you go 45.7 divided by, now I would throw a bracket down, and we're going to say it's the log of the value. So log, and again, we don't need to have the, so I can just go 2 divided by 100, the log of the value divided by the log of the base. And I could work it out, 0.5, and I can just write it as this. And you notice that I want to divide by this when it's worked out. So I've got this divided by this, one more bracket. So the entire denominator is enclosed in a bracket, so it'll do this first. And then divide that, and we'll get our 8.1 days. Okay, so the half-life of the radioactive iodine 131 is 8. It's rounded to the nearest tenth. So here's another example. This one is for advertising dollars spent on cars. And the formula, excuse me, is 0.15 E. So remember, E is Euler's number, the base of the natural logarithm. So we use ln, ln, instead of log, or it's a log, excuse me, base E, to the 0.3 T, where T is the time in years after 2000, plus 0.78. And so the question is, let's do an analysis and figure out when will $3 billion be spent. Okay, so M is the money in billions that's spent. So 0.15 E to the 0.3 T plus 0.78. So the idea is, let's isolate this. Okay. So step 1 will be to subtract 0.78 from both sides. So 2.22 is equal to 0.15 E to the 0.3 T. And we can't use any of our laws or any of our solving things when we have an exponential function times something. So we're going to divide both sides by 0.15. So that'll give us 14.8, right? You're just using your calculator, is E to the 0.3 T. And now we have an exponential function, so we convert that to log form. So we have log base E. Well, the way that you write log base E is ln. The ln of what? What value are we going to end up with? So the ln of 14.8. Remember, a log or a ln is an exponent, and that's the exponent, so is 0.3 T. So T is equal to the ln of 14.8 divided by 0.3. Let's pull out our calculator. turn that on. Let's clear it. So ln 14.8, and we got to close the parenthesis, divided by 0.3, excuse me, which is 8.98. So that's 8.98 years after 2000. Which, now, normally we would just round that and say it would be in the year 2009. So, and actually, you can make an argument and say this is actually during 2008, like 0.98. So, like if I subtracted 2008 and multiplied that, because that's a part of a year, you know, it would be the 358th day of the year. Right, so about a week from the end, say December 24th, 25th, be around Christmas. I suppose they might do a lot of car advertising around Christmas. So T is equal to 8.98. So year, and that's years after 2000. So in what year? In the year. Let's say late. Let's say very late in the year 2008. And I think if we were to say 2009, nobody would really fault us for saying that. Okay, and let's end this here. We've covered all the stuff we need to for this particular thing.